Hello students, today we will do very important and important topic from pointers part section of your syllabus, dynamic memory allocation in C. It is very important topic for theoretical paper. In theory question comes on the main headline, what is dynamic memory allocation and what are the functions used for dynamic memory allocation. So let's start the topic. Now, in dynamic memory allocation, first we need to understand the word dynamic. Let's compare the dynamic word with static. Static means when there is no change. Dynamic means the thing has frequent changes. Now it is regarding the memory term. So when memory, we don't need any change in the memory. When we have declared that memory, then that is a static memory. But after declaration of memory, we want some frequent changes, then it is a dynamic memory. So how to manage the dynamic or frequent changes of the memory allocation while running the program? This is dynamic memory allocation. And let's take an example of array. If I have declared an array of size 6, now while running the program I require 9 locations of the array. On the spot I want to add or reallocate the memory which I have allocated for 6 locations, 6 integer locations. Now I want it for 9. Or some scenario that I am using the array of 6 locations but I have used only 2. So I should free the space of 4 locations in the array. So this type of runtime requirement is handled by dynamic memory allocation functions, and these functions are available in header file stdlib.h. There are 4 functions: malloc, calloc, realloc and free function. And pointers concept is used while handling these functions. Firstly, I will discuss a small term, dangling pointer, before coming to malloc and calloc. Dangling pointer, we all know pointers. Pointer holds the address of the variable. Means pointer points to that location. Suppose pointer is holding that array. But while running the program, you don't require that array and you have freed that space. Means now there is no array allocation, no arrow allocation, but you have freed that space. Now that pointer is becoming dangling pointer. uh, you can imagine that like in the in my hand, if I am holding my bag, clear, my handbag, but somebody snatched that bag, somebody taken that handbag, but I don't know, because my position in the hand is like that, my hand is gripping the handbag's handle is like that, I am in the same position. Pointer which is holding the memory which is freed by someone else, that pointer is known as dangling pointer. Means when you are pointing to some memory, you are holding the address of memory, but that memory is not now not available now. That pointer is known as dangling pointer. Pointer pointing to nothing is known as dangling pointer. Now come to the malloc function. Try to understand the malloc function, then you will be easily getting calloc, realloc and free function. Now malloc, M stands for memory, alloc stands for allocation, so it is for memory allocation. You need to understand the syntax of this memory allocation. I will discuss in reverse order. Firstly I will discuss the example, then I will come to syntax. Let's focus on the green box on the slide. Int star ptr is equals to int star malloc 5 star size of int. Come to the bracket of malloc. 5 star, star is multiply symbol. Size of int, you all know that size of int is 2 bytes, but here from with the help of yellow arrow it is marked as 4 bytes. We have not discussed this point in the class, that int size is 2 bytes for 16-bit compilers, but today nowadays 32-bit and 64-bit are common. In those processors the size of int is 4 bytes. So if our books are according to the old processor, so always there is example of 2 bytes, and we will discuss many examples according to 2 byte scheme. But practically in the latest machines the size of int data type is 4 bytes. So 5 into 4 is 20. So with the help of malloc function you want to allocate the memory of how many bytes. 5 multiplied by size of int means 5 into 4, 20 bytes of memory. And that 20 bytes of memory you want to hold, you want to give the address to which pointer? PTR pointer. PTR pointer is of type int star. So you want to typecast that type in the beginning of malloc also. The malloc function will return the address and you are typecasting that address to int star. So you can see in the beginning of the malloc function one bracket is there and you have written int star, means you are typecasting the address to int star so that that address get copied to PTR. So PTR holds the address allocated by memory allocation function of size 20 bytes. Malloc is a method used to dynamically allocate a single large block of memory with the specified size. As you can see the syntax, PTR is equals to cast type star, means you have to cast the type of the pointer according to the PTR, then malloc and byte size, how many sizes you want. If there is some issue in assigning the value, as there is no memory in the computer, or there is some error comes, and malloc will return the null pointer to the PTR. Now this 20 bytes of memory is booked and the address is holded by PTR. Now next function is calloc. In calloc function there are only two differences. One small difference is in syntax and other small difference is when the memory is booked, the initial value is not garbage value, all the values are 0 by default. Let's come to the green box. Here again I want to book the memory. See the bracket of calloc 5. We are not using multiply sign. 5 multiply by signs of int. Here we are using comma. This is the syntax difference. Here you are using 2 argument method. In malloc you were using 1 argument method. You were using asterisk sign. 5 multiply by size of int. In calloc you are using 5 comma size of int. Rest everything is same. And second point is that they assign 0 values by default. To the initial value, to the 0, to the memory locations. So question can come how malloc and calloc are different. So you can provide the syntax and example as a difference method, as well as the main difference to tell it orally in viva or any other interview, that calloc assigns the initial value 0 to the memory locations, but malloc gives the default garbage values. Now realloc. Means you need to revise the allocation. Reallocation means dynamically reallocate memory. Suppose in the starting of this presentation I have told that I have booked 6 memories, 6 locations of array, but while running the program I have the demand of 3 more, so I want 9. So means I want to change, I want to modify the already allocated memory. So realloc function is used for this. Come to the green box. In through PTR, int star PTR and malloc function we have booked 20 bytes and the address is holded by PTR. Now I want that PTR should hold 40 bytes, not 20 bytes. My requirement is 40 bytes. What should I do? I have used realloc function. In the bracket I will say PTR, the old pointer, comma, new size 10 into size of int. Now it means PTR will hold the new size, not the old size of 20 bytes. Now PTR will hold 40 bytes. Come to the syntax blue box. PTR is equals to realloc PTR, which was holding the old size, comma, new size, which we want to assign it now. If the space is insufficient, then pointer will get a null pointer. Last is free function. When we want to free the memory, here is that everything is holded by PTR. If PTR is, we will make, if we take the memory from the PTR, the memory is free. Only one thing is holding that PTR. Like I gave you the handbag example, my hand is holding my handbag and someone snatches handbag from me, then the handbag is free. Anyone can use, anyone can take. I have no right on that. That handbag is not booked by me. So free bracket PTR means we are freeing the hand of PTR, means the memory is free and PTR will become dangling pointer after this situation.